My name is Alistair Donald, and I'm the chaplain here at Heriot-Watt. The chaplaincy lecture has been part of the public face of Heriot-Watt for a number of years now. Since we largely specialise in science and technology, STEM subjects, it's good to remind ourselves that science raises many broader questions than just self-referentially to its own subject, and questions of interest to wider society. So this evening we welcome both students and staff together with colleagues from other institutions and members of the public from the surrounding community. A couple of things just to mention, please. There will be an opportunity to ask questions after the lecture, but we're not allowed to pass the handheld mic, so you just need to speak up and I will relay the question to the speaker if he hasn't heard you. And those who are attending online, you can submit questions via the chat. Second, a video recording in the evening will be available on YouTube in due course. And our speaker, I'm sure you want me to mention this, he has a number of copies of two of his recent books, and there's flyers on the side tables about the most recent book, which is helpfully the same as the title of the lecture. And he's got some discounted copies here, which can be purchased at the end. Well, I now invite Professor Richard Williams, our Principal and Vice-Chancellor, to introduce tonight's speaker for you. Thank you.
Well, good evening, everyone, and thank you very much, Alistair, for organising this very special event. I'm pleased to be able to add my own personal welcome to everyone joining us tonight, both here in the lecture theatre and many I know joining online. You're very welcome. And it's my pleasure to introduce Professor Tom McLeish. Now, Professor McLeish holds the chair of natural philosophy in the Department of Physics at the University of York. And Professor McLeish, we're really most grateful for your commitment in being here and also returning here after a previous visit, I think maybe 4 years ago. After a first degree followed by a PhD in polymer physics at Cambridge, Professor McLeish lectured at Sheffield University before he was awarded a chair in polymer physics in 1993 at the University of Leeds. In fact, where we worked for some time as colleagues when we were both at University of Leeds. Subsequently, he was appointed to the University of Durham, where he served as Pro-Vice-Chancellor for Research. Professor McLeish has enjoyed a very distinguished career, might I say, in the field of theoretical physics. In particular, I know very much that his work has vastly increased our knowledge and understanding of the properties of soft matter, of materials like polymers, and also the physics of things like biological structures. And for this, indeed, he has been awarded many prizes: the Weisenberg Medal in Europe, the Bingham Medal in the USA. He's been elected a Fellow of the Royal Society in 2011 and was made Vice President of Science by the Institute of Physics the following year. He served from 2015 to 2020 as Chair of the Royal Society's Education Committee and is currently a council member of the Royal Society and also a trustee of the John Templeton Foundation and Chair of the Harvard University's Knox Postgraduate Awards. Well, in addition to this very distinguished track record in the physics of soft matter, in addition to publishing over 200 papers in reviewed journals, he lists amongst his research interests the theology of science. His widely acclaimed book, Faith and Wisdom in Science, was published in 2014. And as Alistair has referred to earlier, his book on the poetry and music of science is the subject of tonight's lecture. And that, I think, was published in 2019. His interests in this area are broad and indeed embrace historical studies of medieval science, the study of contemporary relationships between the humanities and the sciences. And Professor McLeish excels in the whole area of really crossing boundaries, being quite unconventional in his approach by joining mindsets and thinking together. And indeed, of course, this is the major focus of his chair in natural philosophy at York. So we're delighted to have opportunity to hear this lecture, and more so that this is so relevant to us as a university here at Heriot-Watt, particularly as we're a multinational university, as we meet here today, a university with some 30,000 students based in 5 campuses in 3 countries, with over 70% of our students not holding a UK residency. Around 1/3 of our students study here in the UK, and 2/3 of our students study outside of the UK. And that means that we welcome people of many faiths, and faith is a subject that students and staff are able to talk about at Heriot-Watt, and I'm very proud and pleased that that is the case. So I think I've said quite enough, and it is now my great pleasure to invite Professor Tom McLeish to deliver his lecture. Thank you very much, Tom.
Well, am I. Vice-Chancellor, University Chaplain, ladies and gentlemen, students, colleagues, thank you very much indeed. I do apologise, the older you get, and I'm now very old, of course, the longer the recitation of one's CV actually takes. They say that just before you die, your whole life flashes before you. I just hope it doesn't work the other way round, as it were, in the light of the Vice-Chancellor's generous remarks. But seriously, it's really lovely to be back here. I don't know if I'm the first chaplaincy lecturer to be invited for a return trip. I had a wonderful time when I was last here, so it was very easy for me to accept, and I've enjoyed not only today, but yesterday too, with colleagues and students at the chaplaincy and at the Curry Kirk. So let's press on with no further ado, and welcome to this discussion, where the key word is creativity. And let me explain why creativity. The reason for this whole project, really it's a report on a project of mine as a scientist, but one of my activities, that I enjoy most, is visiting schools. As Richard was kind enough to mention, I was involved with the education work of the Royal Society for a number of years, and that meant not only working with the Department of Education, and it's relatively high level nationally. I really much enjoy going to schools and talking with pupils doing all subjects, and I particularly, because you're so far ahead of us here in Scotland than we are in England with our very divisive and siloed A-level structure, more controversial remarks promised anon, but I love going to sixth formers and asking them, if they didn't do science, I'm not blaming them, but why didn't you do science? And it was this response that most got me worried and pained, because time and again I heard the response, I didn't want to carry on studying science because I saw no room for creativity or my own imagination in science. And then I'm thinking, what sort of a bad job have we done to give the idea through our education that science is some form of rote learning or recipe function, when it's actually to reimagine the universe? So, a project. Now, of course, this is part of a wider question, which goes often since C.P. Snow gave his lectures more than half a century ago, the two cultures issue. We have, and our universities are still, this one least of many actually, so bravo, but we all struggle with this division between the arts and humanities on the one side and the sciences on the other. Those of you who've been on university executives will undoubtedly have also observed these sort of inter-faculty wars and financial issues and resource issues, which are an echo of a more substantial academic issue of fragmentation of the way we divide up our disciplines, and the way they map onto the world. But if you look at the world doesn't know about chemistry and physics and biology. The world's the world, or French or English literature or history for that matter. The world is the world. Of course, in the century before, we had romantic poets like Poe and John Keats inveigh against science. The philosophy will unweave a rainbow. Empty the gnomed mind, runs Keats' lines in Lamia, his long poem. Not for Wordsworth perhaps, but for Keats and Poe, certainly the sciences were the dementors of the academic world. J.K. Rowling's Harry Potter's, the dementors, those that suck all the life, all the breath, all the happiness and joy out of the world. That's according to Keats what science does. Or the earliest citation I can find for the differentiation of creativity from the natural sciences is this by Blake, which is written in the very early 19th century. My task, says Blake, is in the grandeur of inspiration to cast off rational demonstration. Bacon, Locke, Newton. I will not reason and compare. My business is to create. And although I adore Blake's poetry, he's one of my favorite English poets, and blazoned with imagination. But there he is painting Isaac Newton at the bottom of the sea, transfixed in attention by a geometrical diagram and ignoring even the marine beauty around him. What was Blake right? Well, because there are other voices. There's another side to this historical account. Ada Lovelace, daughter of Lord Byron, a poet herself and a mathematician, talks about her mathematics and her early computer science, perhaps, in very different words. Those who've learned in her biographical notes, she writes, to walk on the threshold of unknown worlds, by means of that are commonly termed par excellence the exact sciences. Pause here. I'm very happy to be called a natural philosopher now at York, but I do wonder whether we've missed a trick here, as scientists. We should call our departments those who have learnt to walk on the threshold of unknown worlds. Very much prefer Lovelace's words. Right? May then, with the fair white wings of imagination, hope to soar further into the unexplored amidst which we live. She knew that imagination is core to the mathematical enterprise. And by the way, averred that in her personal experience, the best preparation for writing a fresh poem would be a week studying mathematics. Jumping on more than a century, Richard Feynman had, those of you who know his very amusing personal biographies, was immersed in this two cultures discussion, one at Caltech. He had many friends who were artists, and he would debate with them whether science draws the aesthetics and draws beauty out of the world. And his view was that he couldn't understand how science could ever subtract from the beauty of the world. When discussing the aesthetics of a flower, for example, he said, well, I'm sure, to his artistic friend, maybe I don't have the sensibilities at the level you do, but when I see a flower, not only do I appreciate the beauty of the petals and its form and so stamen and so on, but I also imagine inner worlds in the flower, the cells, the complicated biophysical actions, the way that the flower dyes have co-evolved to emit and fluoresce in ultraviolet with the eyes of the insects that pollinate the flower. And there is a beauty there too. And Einstein, sooner or later, we have to consult Einstein, don't we? Who used to say simply, knowledge is limited. Knowledge doesn't get science very far. Imagination is more important. Imagine encircles the world. So our task is to discover what these people meant. And here is the project I undertook. I thought I would ask, not only by their writings, the great creative scientists and artists of the past, but I'd have conversations with anyone I could find who would talk to me today, who I particularly admired in art, poetry, musical performance or composition, engineering, mathematics, biological physics, are all there. And the question I asked all of these people was to tell me a story, choose something they'd achieved. Might have been a poem or a play or a picture. Might have been a mathematical proof of a wonderful theorem. It might have been a lovely piece of physics or chemistry, whatever. Choose something that they felt they were most pleased with, that they'd given the world. It didn't exist before. And tell me the story. Tell me the story. Of course, it takes a little while to persuade the scientists quite what I wanted from them. Because what you tend to get is the précis of the paper. You know, no. I don't want you to cover the tracks. I don't want the finished article. I want the initial idea. I want the story. I want the dead ends and all the mistakes and all the things that didn't work, the desperation, the deserts of non-inspiration and the whole story, right? Eventually they get the idea. Sometimes takes a little wee dram to persuade them to open up in that way. And my idea was, there's got to be a book in this somewhere, and I want to get this out. My idea was that I'd probably write something along the following lines. That there'd be a few chapters on the work of creativity in the sciences, how imagination works in physics or in chemistry. And then I'd have some chapters on, comparative chapters on how it works in music and art. And then maybe I'd finish with a lovely little conclusion, nice little undergraduate essay, comparing and contrasting the two. And I discovered you can't write that book. No one can write that book. That book does not allow itself to be written because that isn't the way the world works. I discovered to my extreme fascination and actually joy that the stories I was hearing and the structure of the creative process had so many commonalities between the arts and science. I couldn't even tease them apart. Now, I'm not the first to have done this. There are other accounts of the creative process in the literature, but there are fewer who've gone native actually, and asked individuals who maybe aren't so necessarily famous to tell me the story. So because time is limited tonight, and because I'm sure everyone has important family contacts to make on Facebook and so on, I'm going to summarize the entire talk in two slides. And then after that, I'll fill in the rest of our time till Q&A with details, okay? So you only need to pay attention for the next two slides, and that's more or less it. And then anything else is sort of optional extra, okay? So here we are. Instead, no, it's not just one mishmash. I did find that one could categorize creative faculties or modes, but they weren't the artistic mode and the scientific mode. There are many ways of doing it. I thought it was convenient to choose three creative populations of activities. The first is the visual. Many people think or imagine visually. Well, of course they do. Fine artists think visually. They're making visual products. Many scientists think visually. I'm one of them. But intriguing, not all. Then, of course, there's the textual mode. Poets, writers, think in words as well as express in words. But it doesn't stop there. There's an extraordinary story to be told, and I will tell it tonight, of the cousinly relationship over intellectual history of the novel, fictional literature, and experimental method. I kid you not. It was Pat Wall, my colleague at Durham at the time, professor of English, who said when she noticed I'd begun this project, she said, Tom, you do know, don't you, that the coincident origin of the early English novel, late 17th century, and experimental method, late 17th century, is not a coincidence, don't you? And I said, I'll tell you more. And then there's a third way, which is a wonderful thing, because you might imagine that when there are no pictures and no words, there's nothing left to create through and with, but there is. There's an entirely abstract set of spaces in which human beings can somehow create, a completely transcendent space that one cannot write about, really, you can try, but you can't write comprehensively about, and you cannot draw or illustrate. And those are the abstract worlds in which mathematics and music live. Now, I don't want to be naive about the links between music and mathematics, but people talk about it all the time. Oh yes, you know, Jessica and Johnny, they're very good at horn and piano playing. Of course, they're good mathematicians. Why? Of course. But there are links, and we'll explore them. So that's the snapshot. That's the synchronic, if you like, posh academic language, view of the results of the project. There's a diachronic or history story to tell as well, which I have heard so many times. I want to call it the creation narrative. Now, of course, we know that all civilizations have their creation stories, their myths and so forth, right? That's not what I mean by this. I mean one of the 7 great plots, actually it's the 8th great plot. Chris Booker, I don't know if you've read Christopher Booker's account of the 7 great stories. So the idea is that there are only 7 stories, right? And each story is one of them. You know, says there's the great battle, that's the Iliad, right? And all other stories about battles. There's the great journey home, it's the Odyssey. And Homer got 2 of these ones going. And then there's the girl meets boy, boy meets girl, and it's wonderful. That's the romance. There's the girl meets boy, and the boy meets girl, and it's terrible, and they all die, and that's the tragedy, and so forth. There are 7 of them. I can't remember all the others. But there's an 8th, which is the story of one of the most human activities of all. It's the story of how human beings bring de novo ideas, pictures, creations into the world, this miraculous ability to create. And it goes something like this. You have an initial idea. It could come from all sorts of places, but there's something you see in the distance that you want to do, a scene you want to paint in a way that will get underneath it, a story you want to tell that will reflect what human sacrifice means, a theorem that you just believe in your mathematical bones must be true, and you think there's a pathway to it, and so on. You see, it's a distant vision. You can articulate it, but it's still blurry, because of course if you had a clear vision, you'd have already done it. You'd have painted the picture or proved the theory. You see, it's a distant vision. What that gives rise to is an immense desire, a motivation to paint it, to get there, to prove it. And that derives a series of actions to attempt things that have never been done before, that are difficult. I think that's where the weightlifting guinea pig comes from. I'm not quite sure where this gets, but that's, you know, and because it's difficult, because it's never been done before. And as a result of that, the common experience for anyone creating anything that's never been done before is failure. Scientists should talk about failure far more often than we do. Constructive, anticipated failure. What makes a successful, maybe academic of any, or creative person, well, everyone's creative. We'll talk about abstracts of life in general in a minute. It'll turn into yesterday's sermon, but how we respond to failure is far more the making of us, is it not, than what we do with our successes. And this creeps up all over again. And sometimes everything grinds to a halt. You know, our PhD students typically recognize this in the dreadful desert of year 2. You know, when none of your first experiments or your sources work out, or your transcriptions you can't get to the documents, or someone else has done the thing, and there's a great big desert. And then maybe after leaving the problem for weeks or days or months or even years in some cases, not always, but many times, there is this phenomenon, the aha moment, the muse, as if from nowhere, some idea is whispered into your inner ear, and you go, oh, that's it. That's the way. Jacques Adamard wrote about this in his marvelous turn of the 19th century account of mathematical creativity, of this extraordinary role. Of course, it's the subconscious. There's not a muse. There's not an angel or anything. But there is our extraordinary, subtle subconscious, which isn't just there to keep our heart pumping, or breathing, or or being able to drive when we've learned to drive, or all those subconscious acts, motor acts, that we must not think of, because if we think of, we fall off the bicycle and so on. It's also creative in this mysterious way. And this gives rise to great joy, because although one still hasn't achieved the goal, you've seen the way to it. Do you notice something else about this story, which we also need to be much more honest about? I found that the purest of pure mathematicians, from them all the way through to the most romantic of poets, all of them, in their creative processes, however differentiated they are, entangled the cognitive with the emotional to a degree that was impossible to tease apart. All creative acts involve aesthetics and affect as much as they do cognition and logic and reason, which is one reason why Blake was happily wrong. If he just talked more with the early natural philosophers, he would have heard them emote in the same way that he knew in his own creativity. Anyway, so that was it. That's the story. Details. I'm going to fill a few details of the visual imagination. Let's talk about visual imagination. Let's let Einstein talk about visual imagination. He said that words were difficult to him. Read this: laboriously sought as a second stage. The visual, or even muscular type. His wonderful creation of relativity is very visual, dreamed phenomenon. The Gedanken experiment, the thought experiment, is all visually imagined. And I can't help as a theoretical physicist. I thought for a while, why do I like Impressionist art so much? Of course, it's because when it comes to visual art aesthetics, I'm a naif. You know, it's just fun. Of course, Monet, lovely. But I think there's a bit more to it than that. So this is my favourite Monet. Of course, you can't appreciate its. I mean, this picture I can see is better than that one that you can see, but the original hangs in the Philadelphia Art Museum. It's wonderful. It's been in private hands most of its life. It's come into the public domain only relatively recently. It's unusually one of his series he painted in Antibes in the south of France, under that glorious Mediterranean light. He's most known for his northern French light, of course. And I'm fascinated by the visual representation. There's an extraordinary story behind this particular painting. You know, the best of paintings sometimes can remind other people of the scenes. You know, when an artist really is successful in evoking a scene, and then someone else sees the painting. Oh yes, I was in Paris. I saw. This worked the other way around. So when Van Gogh went to Antibes and stood there and saw the sea, he was reminded of the picture which once hung in his brother's shop in The Hague. So this is glorious. It also reminded me of why we use the visual metaphor for understanding. Oh, I see it now, we say, when we have recreated in our minds the piece of science or the poem or the mathematics or the idea that someone is trying to teach us. When you stand in the art gallery in front of this picture, not only do you know that the sun is setting on the right and that the wind is blowing in your face because of the onshore breeze because it's sunset, you see the trees moving. And that's because Monet understood that vision, Plato was right. The original story of vision, original account of vision that Plato has in Timaeus is that vision is so extramissive. Some of you, I'm sure, will know this. The idea is that visual rays weren't incoming into the eye, but were emitted from the eye. We literally looked at things. We were sending out visual rays. Now, because it's not very good at explaining why you can't see anything in a darkened room, but it is good at explaining why it is that we can focus, how we make a sense of all these incoming, this morass of visual information. That was what motivated this theory. But of course, in much more recent psychology of vision, cognitive neuroscience of vision, has told us that Plato is partly right. Optically, it's all intromissive, but psychologically, the only way we can interpret vision is by, this is for Bayesian, if you like, by projecting possible interpretations from our learning onto the visual center in our brains, which is why they can be fooled. Who sees little rotations going on there? Anyone see things turning around? Yeah, very good. Yeah. Now, of course, you just won't believe that it's a static image, and because it's on a screen, I could have put a moving GIF, couldn't I? It's not. This is Aoki's Kitaoka's, one of his rotating snakes illusions. It is because we are projecting interpretations onto the world that clever artistry can fool those. All the motion you may or may not see there is entirely created by you. So the visual method, the point is, vision is itself creative. We create most of the worlds that we see. I've known this in my own little scientific world. Rich was kind enough to mention that I do a little bit of work in biological physics. Here's a picture that I remember looking at about 20 years ago, and as I dozed a little bit in the lecture theatre, I saw that picture come to life in much the way that I've just shown you the illusion come to life. This, by the way, really is moving. It's David Blundell's, my former PhD student in Durham's, computer simulation of the catabolic receptor protein. And I wanted just to indicate how my own story of imagination worked visually. It's because I knew in my heart, for the physics I do, that the biological static structures on the left are only half the story, and that at room temperature, all of molecular matter is in continuous random motion. And one of my long scientific questions has always been, why is it, how is it that order, information emerges from this chaotic sea? So there's a little bit of a personal visual story, and back to Einstein itself. Perhaps the greatest imaginative act of physics of the 20th century is to reconceive gravity as geometry. Rather than a force, gravity is the curvature of space-time. There's the canonical diagram of the orbit of the satellite orbiting a black hole or a star, in the same way that a ball would circulate around a curved surface. Now, of course, I'm keen during this project to ask who in the philosophical tradition has spotted this. Where in philosophy is there this nuance of reflection on the scientific creative act? I've honestly had to go back to the 13th century before I found a sufficiently resonant account. One of my most delicious interdisciplinary projects as a scientist has been working with medieval scholars to read the scientific works of this gentleman, Bishop Robert Grosseteste, became Bishop of Lincoln in 1235, but lectured the quadrivium to the mathematical arts, that is, the liberal arts generally, to the Oxford Franciscans in the early 1220s. And right in his commentary of Aristotle, this is the red-hot scientific resurgence of Aristotle in the Latin West, about the penetrating power of the mind's imagination in science. This neologism, due to James of Venice, solertia, but it really means the scientific imagination. Read it through with me. Does not rest on the outer surface of an object, but penetrates to something below the visual image. For instance, when the mind's eye falls on a colored surface, it does not rest there, but descends to the physical structure of which the color is an effect, then penetrates this structure until it detects the elemental qualities of which the structure is itself an effect. It's beautiful. You could give this to a science undergraduate today and tell them this is what you're going to do. Now, snapshot of visual. What about the textual? I said there was this story. I said there was a cousinly relationship between creativity in the novel and in experimental method. And quite rightly, of course, you didn't believe me. You thought I was talking nonsense. Well, if you don't believe me, why don't you believe Joseph Priestley? If we go to his lecture, not mine, given a bit further south here in Warrington in 1761, and where he says, works of fiction resemble those machines which we contrive to illustrate the principles of philosophy. Natural philosophy, the old word for science, right? Globes and orreries. It was obvious to him. What's going on? Well, maybe Iris Murdoch can help us. Let's ask Murdoch, wonderful novelist and philosopher herself, about the other flip side of the coin, the novelistic writing. She says it enables an attention to the inexhaustible detail of the world, the endlessness of the task of understanding, the apprehension of the unique. Now, I invite you to replace Murdoch's world's novelistic writing with experimental science and parse the sentence again. What is going on? Well, what's going on in the 17th century are the creation of the first novels like this one by Margaret Cavendish. And this is going to reflect very much on what we're talking about. Margaret Cavendish put in novelistic form possibly the first work of science fiction, Blazing World, a new world in the sky one gets to via the North Pole and the snowy north where there are strange creatures and aurorae, and I think Philip Pullman's read this one. And where the scientists fall out because of their disagreement over what they see through their telescopes and their experiments. See, Cavendish, who's my favorite 17th century philosopher, spotted the problem with experimental method. She could see that it's obviously foolish to anticipate that experiments could ever teach us about the natural world. You see, we're so used to experiments working, we don't realize that they obviously shouldn't. Let me explain why. Experiments, look at the world out there. Open the door. Look out the window. Wind's blowing, complex. It's a huge world. It's interconnected. It's got thousands of ingredients and pieces. It's behaving in a thoroughly nonlinear, unpredictable, interconnected way. Now look at an experiment. It's got few ingredients and pieces. It's simple. It's disconnected from the world. It's isolated, and it's entirely artificial. Do you see my drift? How could we ever expect to learn anything about the complex, interconnected, and multi-component world by doing anything as artificial and simple and disconnected as an experiment? Not a chance, right? And yet it works. Why? And how was it ever imagined to work? It's the first time where we have to touch the world of theology and history, because it worked because of people like Francis Bacon and Robert Boyle, who drew on a theological narrative to tunnel through that barrier of obviously won't work, and imagine my experiment would work. So there we go. Here's Robert Boyle, who used the same comparative metaphors, who talked of the world as a great book. God wrote a first book of Scripture and a second book of the world, and uses writing and reading as a metaphor. Daniel Defoe, on the other hand, other candidate for first English novel, talks about science more than he talks about literature. And so on. I'm going to skip over, but don't read the stuff here. I did it in the book, if you ever want to read the book, I did a comparative side-by-side comparison of The Art of Novel by Henry James, who talks about the stories of ideation, observation, incubation, illumination, and verification, which is the story I told you in other words, with The Art of Scientific Investigation, a less well-known book by physiologist William Beveridge, early 20th century, who uses Henry James' very words, I don't know whether it's a coincidence or deliberate, to talk about the scientific process. But you can see why, let me just try and persuade you why experiment, the imagination of experiment and the imagination of the novel might have arisen within the zeitgeist of the same century. What they are is a supreme new confidence in human creativity as applied to small worlds. You know what a novelist does? They create their own world. It's a little world, a few characters, a place or two. And then the extraordinary thing about people like Henry James's observation, look at that second paragraph. My business was to watch the subject's turns as the fond parent watches a child perch its first riding lesson for development. Novel writers use the term observation to describe their art far more often than you'd ever believe. Experiments also set up small worlds and watch what they do. There's a sort of spirit which links these two together. Now, if it is true that experimental science and the literature of the novel go hand in hand, what is the partnership of poetry? And what is the partnership of the concomitant theoretical science? Well, might they go together? And the new revised edition of Poetry, Music and Science, which you can get with the flyers, has a new chapter, because I have to admit, 5 years ago, I didn't believe that poetry and, although I understood now that novels and experimental science did have something to do with each other, I didn't understand what Goethe claims, which is that science and poetry, particularly theoretical science, share a common origin. And this is the second point at which we're pushed to theology, because what I have found in both my own thinking and writing is that whenever one wants to think about two of the minor trinity of theology, science, and poetry, one has to talk about the third. So when trying to bring science and poetry together, one's pushed into theology. Malcolm Guite, who is talking about poetry and theology, starts to find that he's talking about science or materiality. Ursula Le Guin, great writer of science fiction, but so much more. Science describes actually from inside, poetry outside, poetry from inside. Science explicates, poetry implicates, both celebrate. She really understood the complementary interweaving of science and poetry. And Mary Midgley, for those of you who know her extraordinary philosophy, uses the metaphor of the science-poetry relationship to discuss her inveighing critique of material reductionism in the book which she called Science and Poetry, which isn't so much about science and poetry as reductionism. Now, this is the reason why I wasn't sure that poetry and science had really married each other again, was that in the preface to the Lyrical Ballads, William Wordsworth, second edition, prophesies a time when science will inspire poetry afresh. The remotest discoveries of the chemist, botanist, will be as proper objects of the poet's art as any upon which can be employed if, and he makes it a big if, he says, if they are commonly experienced and understood by all enjoying and suffering human beings. He knows that poetic metaphors work when we all get it. So science in poetry will only work when we all know about chemical reactions, you see. This is why I thought it didn't really happen. But it has happened. There are extraordinary anthologies of science-inspired poetry now for the taking, hundreds of them. This last one, extremely moving. Rebeccaelson, astronomer, died of leukemia in her late 30s, wrote the most gorgeous poetry about dark matter and the Large Magellanic Cloud in the 1990s. Do read. If you want one piece of good advice tonight, don't buy my books. Buy Rebeccaelson's Responsibility to Awe, read it and weep. That's why Goethe was right. You see, nowhere would anyone grant, he writes in Andi Morphologie, that science and poetry can be united. They forgot science arose from poetry and failed to see that a change of times might beneficiently reunite the two as friends. Now, why is science like poetry? I've tried to convince you that experiments are like novels in a soundbite. Let me try and convince you that science is like poetry. Yeah, it'll take 2 minutes. We've got 2 minutes. And then the music, and then we're done. Right? Almost. What's a poem? I don't know if you, I still remember, I don't know why I remember this, of all the thousands of lessons I had at school, I remember the day our English teacher told us about the sonnet. No idea why. But I remember what he said. He said, listen, boys, I'm afraid we were, all, you'll only ever have to write a sonnet when and if you fall passionately in love. So the reason for this is that, of course, when imagination is so overheated and overfueled, if you just wanted to write a letter, it would just pour out and this mess of hot emotional stuff, incoherent. Form is there to make sense out of explosive creative imagination. Right? So it's the outward motion of creativity, imagination gets constrained by form, so you have something beautiful and understood at the end. Right? Can I compare thee to a summer's day? Now, if that is true, what could constitute or what could call upon the greater imagination, energy of imagination, than to reimagine the entire universe? Because that is the task of science. And what could constitute the tighter form than to make sure that imagination is conformed to the universe that we see and observe? Don't know if you buy it, I'll find out at Q&A. Science as one giant poem. Margaret Cavendish again. Oh, historically, yeah, the 17th century. I'm not so sure that were it not for the rather dry, superficial, prosaic tastes of Henry Oldenburg and the early fellows of the Royal Society, that poetry wouldn't be the standard form of science. It was in the mid 17th century. When Margaret Cavendish wants to think about atomic structure, she writes poetry about it as part of the inventive thought process. Atoms, hollow atoms, there we go. And as I mentioned, it becomes I mentioned Mary Midgley already. We've got time. Yep, right, we're on. I've not done my 40 minutes yet. Mathematics and music. Let's just briefly kiss as well. I mentioned Henri Adamar. Let's look at Poincaré, who reflected as a mathematician on those products of unconscious activity and calculated that if the unconscious mathematical mind were merely working through combinatorics of possible theorems, it would be impossible to alight on the right one. There has to be some sort of shadow aesthetics going on. George Steiner, the emotional sensibility, great human being, post-Holocaust Jewish commentator on literature and science both, gave a wonderful Edinburgh Festival lecture here in town a few years ago on the imaginative pink rosy future of the sciences. Talks about music as the allegory of mathematics. But what I saw, my aha moment, was when sitting down next to my musicologist friend and colleague at Durham, Julian Horton. This was lovely because obviously if you're going to write a book about creativity and imagination, then it's no good just waffling on as I've done with you today in abstract. You've got to talk about details. You've got to, exemplars. But the nice thing is, well, I guess I showed you my favorite Monet example. You can, it doesn't matter what you choose for examples. You can choose your favorite mathematics and your favorite music. So Schumann happens to be my favorite. Actually, both Robert and Clara are my joint favorite composers. And one extraordinary piece of music is Schumann's Concertbook for horns and orchestra. And I really wanted to talk through the creative process of that as an exemplar. Julian had a project on 19th century orchestral music and said, well, would you like to do this together? So this was a great joy. And at one point in the process, he looks up at the ceiling and he says, what distinguishes composers of the first rank is their ability to set up strategic problems of harmony and to solve them. And you see, I already knew, because of the mathematics that I do and the real mathematicians I know, that what distinguishes mathematicians of the first rank is their ability to set up strategic problems of lemmas, of sub-theorems, of pathways that you cannot see your way to the end of the closing harmonization, the closing residual symphony, any more than you can see your final way to the coup de grace of the theorem. But you feel your way forward in imaginatively creating independent harmonic or pre-theorem structures. That, I think, is what allies music to mathematics. And of course, the transcendent nature of this means that we have to somehow notate our thinking and our records in weird dots and lines. Well, half the people here will be going, oh no, don't get that to the left, and the other half will be going, oh no, don't like that to the right. But you've got to just see these notations and look at them and appreciate their beauty, the ups and downs, their patterns, in order to see through them, perhaps iconographically too, a wonderful piece for four horns and orchestra, or a wonderful mathematical representation of how Brownian motion sets physics and deeply connects the response to randomness in all of matter. There are other structural comparisons. We're running out of time, so I won't hover over this, but take the first one. One compare Schumann and Hadamard, Schumann and Poincaré. Schumann was also, by the way, not just a great composer, but a wonderful writer on music. If anyone can, it's him in the Neue Zeitschrift. Poetry vibrating into the future. The mathematical argument is to be compared with the act of recognizing a person. This act of recognition of the subconscious role, and so forth. And I wanted just briefly to mention my great friend and colleague Judy Cornfield, who's given me the greatest exemplar of an extreme example of a desire-fueled scientific and engineering project. And Judy is the only scientist I know who stood up at a major convention and told the story to everyone with the twists and turns, the lack of funding and the emotional desire. And half of her audience were in tears at the end of an entirely technical talk about a piece of polymer chemical engineering, because it's all about designing a polymeric additive to jet fuel that would mean that would never ever have to happen again. And they succeeded, emotionally fueled after 9/11, because the airline industry still hasn't adopted the technology. Julie can produce a 0.1% additive to jet fuel that will allow you to put out fires with jet fuel. And it still fuels jets. It's quite wonderful. And do you know something? The 13th century philosophers knew this as well. This is part of this entanglement of thought and feeling. We shouldn't diss emotion. Back to Grosseteste's comments on the liberal arts, the works within our capacity consist in the mind sight and the desire, or even this haptic thing that Einstein was talking about, bodily movements. And then he talks about the way all these things are connected in any of the liberal arts, which of course include the things we now call the sciences. So it's time to just finish, but we've quoted Einstein. We can't really finish without quoting the Bard, can we? And we mustn't. And I think we might leave the story here. And Malcolm Guite, the poet and theologian and poetry scholar, who's also now finding himself talking about science, also independently alighted on this wonderful quote, Act 5 from Midsummer Night's Dream, when Theseus, Lord Theseus, all the lovers are back with the Theseus, the big party, all the right ladies are with the right gentlemen, and all the fairies have gone away, and it's a happy ending. And Theseus gets up and talks about the role of the lover and the king and the poet. And he says this, "So the poet's eye in fine frenzy rolling doth glance from earth to heaven, from earth to heaven, heaven to earth. And as imagination bodies forth the forms of things unknown, the poet's pen turns them into shapes and gives to airy nothing a local habitation and a name." And that, if it's the task of poetry, is surely the task of science, which is to make friends again to an inhuman and material universe in which we feel out of joint and out of place. But through rebuilding its image in our minds, gives it a local and human habitation and a name. And that points to another task that science has forgotten for a long time, which is to share this, as Wordsworth taught us we must so long ago. It is so important, a human need, to make the unknown known, which is what both science and poetry do, that we must learn to do this better. So with that, I'll say thank you so much for listening to me. Thank you for inviting me.
So thank you very much, Tom. I'll now hand over to Professor John Sawkins, who's going to give the vote of thanks.
Oh, great. I'll come and sit down. Thank you, John.
Line to offer Tom McLeish our most sincere word of thanks for helping us once more explore the interface between science and religion, or rather I should say science, poetry, music and religion. Reflecting on what we've heard, Tom, you have reminded me once again of the risks that we run if we artificially separate out our thinking. You've reminded me of that C.P. Snow work 60 years ago now, and you have reignited a vague sense of lack of ease, that we haven't cracked it yet and that we haven't dealt with it there yet. So thank you for helping us to reflect on how we might creatively bring the different academic discourses into the same space. We know, of course, that there is for many a tendency or a temptation to think and operate and function in our own worlds. Why? Because it's known. Why? Because it's safe. Why? Because we don't want to take a risk. Or rather, we don't want to risk needing to change the way in which we structure and frame how we think. So thank you for inviting us to take that risk. Thank you for engaging with us and helping us catch sight of new ways in which we can frame the way in which we think. Thank you for helping us not just to consider new modes of thought, but how we might employ a fresh way in which how we might think is important as well. So thank you not just for the hike, but for the real challenge to take that risk in the way in which we think. The need to ensure that conversations which have, from a historical point of view, taken part in separate spaces are joined up is at the heart of what we seek to do in the chaplaincy lecture here, year after year. And it's perhaps just in this way that we will advance our understanding of what it means to be human, how we relate to each other, and how we inhabit the earth. And as I close, I also want to say how pleased we are to have been able to share this online, and so to have a mixed mode lecture this year. So as I close, all that remains for me to do is to invite us all in the hall here and online to offer our lecturer this evening, Tom McLeish, a very warm round of applause. Tom, thank you.